Hello, welcome back to BLENDERSUSHI live noding. In this episode, we're gonna use Animation Nodes and Sverchok to do the similar thing like before. It's audio sampling. So we have animation nodes here, and then we have, instead of a single data, we like to test multiple data, and let's see how we can transfer this data into Sverchok and then to create something like this. So if you want to see it in full speed, let's switch to 3D view full. So that's definitely a lot faster. We can see this is like that's actually how many sampling, 100 samples. There's actually 100 boxes here, and it's actually rather simple, surprisingly simple, but it's a fun to do actually. I'm gonna start from scratch. It's called Pilot. Okay, I'm gonna use this random music that I made. Basically, from animation nodes, we're gonna output like a spline, and from that spline, we're gonna transfer it into Sverchok and read it, because Sverchok can easily read the spline, and if the spline is animated, of course we can just transfer the data value into whatever we like. So that's yeah, it's gonna be fun. Okay, let's start from scratch. Just real quick, compositing, animation nodes, and then let's use the template still. Sound equalizer, because we want a multiple sample, and lower the sound figure. This is the random sound. It needs to be in the wave format. So just bake the equalizer data. So we have this kind of sampling between 0 and 20,000 hertz. I think the number can be different, but if you're a musician, you probably understand what's the attack and release and all that. So once it's baked, we are good to go. File save as ANSV. This is multiple data sound. We're gonna play a little bit with animation nodes here. Instead of, so currently by default it's asking you for object instances. You don't actually need object instancer. We can just delete that node and then delete this input objects. So now we have these iterations. Iterations number will basically kind of like how many number sample you want for the sound. That's I think the one responsible for that is the equalizer data, this guy. Evaluate sound, and then this has a multiple strength. Equalizer data and goes in here, and there's a mask divide, and then blah 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 here goes into this guy, and we don't need this guy either. We're just gonna output like vector list and plug that vector list, and then here we can specify how many sample we want. Let's start with 50 for now, and here turn off always and this 3, so it's a little bit faster now. With the vector list output, we can simply use spline from points. This node takes points data, and then we don't use Bezier, use a polygon. And the spline output, we need just to one more node here, object output. Plug this guy in there and spline and the output. And we have this guy. And let's play the music. So that guy is actually kind of disturbing the lines, so that's good. we can increase the amplitude. Not that one, actually this guy. So that's yeah, that's much better, and we can just transfer this curve into Sverchok. Now turn on Sverchok and using objects in, and Blender just crashes. We're gonna restart. That's okay because I always save every few seconds, so maybe my computer needs more memory. Open recent file, save as new. So back to Sverchok, new, objects in, get selection, get that object, and then view and check the result. Let's try, have a look. Okay, seems to be working. You see, it looks like there is a delay, but if you're doing it frame by frame, there should be a very little delay and should work. If I use the 3D view full, that's almost like real time actually. It's pretty cool. Okay, so we have curve. How do we measure this this height? If you think about it, if we have a line like in the default positions, the z should be 0, 0, 0. So we basically just need to factor out the points here and then check the z value. That's gonna work for us. Debug. Let's use the stethoscope and check the z value. And you can see, okay, the value is kind of between 0 and 1. So there's like the one that goes over, but that's okay. We can always remap it. So from, we know we need the z value. So plug it into that guy. 0. Let's just say between 0 and 1.5, and then the output should be any number actually. Depending on what we want to do here. We can use line or we can use box, but I think I'm gonna use cylinder in this case. What I'm trying to do is just to instance the cylinder depending on how many points we have, and then control the height of the cylinder based on the amplitude of the value from animation nodes. So let's do that. First of all, the matrix, and so we can actually just use the points from this guy. So if I use a vector in, so we just gonna grab the x but ignore every other value, and then plug that into the matrix in. Just cut that location matrix, so we have the position like the default position of the line before it's being disturbed by the sound. Now if we use the cylinder, by default it's like 32. We don't need that many divisions, so just make it 8. Cylinder has a radius, so we just make it smaller. So we have 50 cylinder here. You can see it here from matrix transformations. There's one more thing we need to do. It's just plugging this value into the height. Now we can test it. It's sort of working. Let's see if I'm missing anything. Okay, let's make it from 0 to... There's like a slight delay, but if we actually use a 3D view full, that's better. Seems like it's a bit cut off right there. Maybe I'm missing something here. Maybe it should be somehow. There's a need a way. We need a way to normalize this guy. So it doesn't get cut off. I think that's actually a little bit better. Alt min, alt max. Turn off caps. Let's see if I'm missing anything. Matrix in. Oh, maybe the clamp. Turn off clamp. Okay, now it's much better. Doesn't clamp. Yep, that's definitely better. 1.5. New, min, and max. Okay, nice. Now this looks much more natural. The cool thing about this is if we go back to animation nodes and increase the sampling, let's make it 100, and go back to Sverchok and update it, everything conform to that. Currently we have control over everything. Like if we want to match the amplitude there, we can do that, but we can always increase it like that. Let's reduce this cylinder into triangle or box. Yeah, that's fine. Let's test it again. Everything is running in full time, so it's really cool. There is another variations of a similar thing, and still pretty basic, but let's say currently we have this thing that looks like a mountain representing the amplitude or the frequency loudness of the sound. If we want to make it so, if we just change the pivot of this guy, we're gonna have like a different result. I'm gonna show it to you real quick. So instead of a cylinder, let's say I'm gonna do it differently. I'm gonna use box, and with this box we're gonna have a box, and with a box like this we can basically control the scaling. Let's try that. Use another vector in, and in the scale I'm zeroing everything out and then scale it slightly so they're kind of next to each other like that with a small gap. What we want to control is the Z, and for the Z we can just plug in the value once again. Now we have a completely different design. This is something that you often see in the visualization. I probably need to look at some of other way to visualize audio, but this is some of the most basic one that I could think of. Try it in a real time. Sometimes actually I like it when the blocks kind of running through instead of static like that. Maybe I can try something here, kind of like a not shuffling, but just like a list shifting. So if I shift the value in here, we can sort of have that kind of if FFT, like a fast Fourier transfer FFT. Yeah. Let me try this. This is just an experiment. Let's try it. It's kind of moving forward. Not exactly FFT, but this is kind of interesting. Maybe instead of moving that way, we want to reverse the value. So math plus or multiply by -1, or actually just use a subtract 1 subtract by 0 subtract by the frame. Oh, it's complaining. Doesn't like that. Ah, that's interesting. The shift doesn't like to go backward. Yeah, interesting. Should be able to go backward. Math. Math. Multiply by -1. Plug in that thing. Plug that thing. It's complaining. Stethoscope. Ah, doesn't give any result. That's weird. Maybe float to integer. That's really weird. Well, I guess we can just leave it like that for now. It's doing this list shifting. Slightly more interesting, but let me try to think of ideas. So list shift. What I don't like is that back. It's a bit like cut off because of the list shift. Alt min, alt max. What else can we do here? Maybe there's other things that we can do, like line, plane, and gone. Analyzer. N-gon. N-gon can give you like a circle, box, plane. Try to think of something. Box, cylinder, sphere. We can always do the noise thing again. Let's say if I'm using like a plane, This is like a bonus. One more thing. So instead of like a multiple objects instancing, we're gonna use plane and let's see, noise, maybe noise. Okay, noise. Oh, no, we have multiple values, so factor noise. Let's try using a line. But we already have line from animation nodes, so what can we do here? Maybe multiple circle, but that's not gonna be so interesting, I guess. Let's try circle and radius. Suddenly have that idea. Circle and radius. Okay, circle, we can kind of multiply the circle to go up. So going up. Okay, I have to kind of visualize this. We have a circle and we want to duplicate it up. So with the matrix, we want to instance it up. So plug the X into the Z. Now we have this guy, and then we simply use the value from animation nodes into the radius. Now we have a different design. Yeah, I guess that's slightly more interesting. Can be even better. Vertices. So we have control over that, so it doesn't need to be circle. Can be triangle. What else? Of course, at this stage you can actually use the skin modifier thing, skin measure. Simply plug in the vertices, edges, and matrix. Turn on live, and we have real objects. This is actually still pretty fast. Okay, there's a lag, but you can do this. I think it's because we have multiple objects here and it's slowing things slightly. Maybe turn off this division view to 0 and then go back. Yeah, that's kind of almost like real time. Yeah, that's kind of interesting. A little bit variations, but you can endlessly have a different kind of visualization. But this is just one of them. So we have single data that we can use, or we can have like multiple data, like in this example from audio. Try to think of other things, but I guess this is pretty much it for this live noding video. If you have any idea, suggestion, just let me know. Yeah, and I'll see you in the next video.